Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of Cloud Tech Thursdays here on OpenShift TV. I am Chris Short, executive producer of OpenShift TV. Yes, I say it so fast I can't even say it anymore. I'm joined by a wonderful team of folks here. I would like to hand it off to Amy Marish to tell us what we're talking about today.
Hi, everyone. I'm Amy Marish. I'm the OpenStack community person for Red Hat, and I'm going to introduce some of my other cloud-related community cohorts. We have Josh Burkus, who is the community person for Red Hat for Kubernetes, and Mike Perez, who is the community architect for the ceph community. Mike, do you want to go ahead and introduce our guest?
Yeah, so we got Blaine Gardner here, who is the principal software engineer on the Red Hat OpenShift storage team, and is a upstream Rook maintainer and containerized storage engineer, specifically, to get that right. And I'm excited here to talk about Kubernetes, CSI in particular, which stands for Container Storage Interface. It's been generally available status in v1.13, and has since evolved to support a large number of vendors and storage formats. And the container storage interface only supports block and file level storage at that point. However, the Kubernetes community is bringing forward an initiative called the Container Object Storage Interface, or as we call it, COSI, to focus on the infrastructure deployment of object storage solutions in Kubernetes environments. So Blaine Gardner, would you like to take it away?
Yeah, I am. I'm excited to talk about COSI. It is, it is very analogous to CSI. It's a common object storage API for Kubernetes. I kind of wanted to start from the point of what is my investment in this? Why do I care about this? I work with Rook and ceph. I'm a maintainer upstream for the Rook project dealing with ceph. Ceph itself is a distributed software-defined storage solution. It's been around for nearly a decade or maybe more now, and provides three types of storage: block and file, which are provided or are part of the CSI initiative, and it also provides object storage. And then Rook is the management plane for ceph in Kubernetes, and allows ceph storage to be mounted into your whatever application pods you have for yourself. And yeah, being Rook object storage is one of our big three features. The benefits of object storage that we see for users are that it's provides unstructured data. There's no real tiering system, but it does also provide a lot of rich metadata, which makes for easier analytics. So I tend to think of Hadoop around that, like being, I want all files bigger than this or smaller than this, or whatever kind of advanced queries you have. And because it's a flat system, it can scale much larger than file system storage. And some of the use cases that I like for object storage are things like all the video and audio that you have in like Netflix, or for gene sequencing files from genomics research, or a little more mundane, like for system backups. And something that we do in the Rook project is we use it to house our Helm chart repository. So it's great for packages and containers as well. And the kind of problem statement here is how object storage works in Kubernetes today. So whatever, quote unquote, big cloud provider you have, generally the workflow is that you create an object or a bucket or a blob or whatever you call it in that your big cloud provider calls it, and then you copy those details manually and you put that in the definition for your application, like a deployment. There are some projects to make this a little easier, which use Fuse, which is a file system in user space rather, to mount the bucket and then be able to access that. But it is still a pretty manual process. In Rook, I think the process is a little better, but it is specific to just how Rook handles it. We have custom resources for creating an object store based on ceph, and then also for creating users for the object store. And when you do that, Rook creates a secret that you can then go and query programmatically to get authentication details that you can just type directly into your user application. But COSI, I would say, the driving mission statement is to reduce the manual steps needed to create and use object storage in Kubernetes. The vision being, what if you could claim object storage without specifying exactly what that is? I just want some object storage, and I can claim it with a standard Kubernetes manifest. That claim will be fulfilled automatically, and then I can access that claim programmatically. Diving a little deeper into the benefits of COSI, it's a Kubernetes Enhancement Proposal that's currently in alpha, but it is like the goal and the plan is that it actually becomes a part of Kubernetes, similar to the Container Storage Interface, CSI, today. So it will be built into Kubernetes. And it takes inspiration from past success in Kubernetes, notably persistent volumes, persistent volume claims, storage classes, and then I have mentioned the CSI interfaces. And I think the chief benefit is that it's more flexible, it's easier to use, and for, coming from the Rook side, it's easier to implement also than kind of writing something ourselves. And another big benefit I see is supporting multi-cloud use cases, which helps reduce vendor lock-in also. And the kind of technicals for how COSI achieves this is it provides resources to users and administrators that they can create to actually get object storage. And from past success, there are analogs here. The bucket class kind of matches up to what a storage class is, and a bucket request matches up to a persistent volume claim. The bucket matches up to a persistent volume. So an administrator can set up a bucket class, a user can request a bucket from that class, and then we'll get a bucket that is created. Object storage is a little more complicated than block or file. It can't just be directly mounted into a user application, but you actually need to get credentials for it. And so we also have access classes and access requests that are created.
Blaine, real quick question.
Yeah.
So you're talking about the storage classes and the persistent volumes, and then you just mentioned block storage as well. So are these persistent volumes block storage or totally related to the object storage?
I would say they're just an existing analog. CSI currently provides storage classes and persistent volume claims for block and file storage, but doesn't really provide any methods for object storage. So that's kind of like one side of things. And then there is the COSI side of things, which aims to provide an analog that fits into the object storage paradigm, where you do have storage you can claim, but it's I think it's just not been around as long. It's not as well defined, and there's a lot more variability. And so I think for CSI, it focuses a little bit more on traditionally what's been available, which is block and file storage. So these are, when I'm talking about storage classes or persistent volume claims, those are existing utilities, existing things that users in Kubernetes can use that provide, I think, a good basis for understanding what COSI is, because it is pretty anomalous.
Okay, and COSI would presumably have sort of a driver structure just like CSI has, yeah?
Yeah. Yeah, CSI also has helper sidecars that are used to help provision and mount storage. There are also helpers for like expanding a volume. And COSI has plans to, following that design, which has been pretty successful, also implement sidecars. And those primarily help vendors. That's not something users really care about, but it is something that I, working on this in Rook, will care about. And then COSI itself also will have a controller, or has a controller, which manages some of the more vendor neutral behaviors, the interactions between, like, okay, when a user makes a bucket access request, it can check if a bucket access class actually exists for that, and then not have to, make the Rook in our case actually check to see that everything is okay.
So does this
then,
help with local storage at all, out of curiosity?
I think the relation to local storage here, coming from like a Rook perspective, is that if you have some number of Kubernetes nodes and you have local storage on all of those, Rook can consume that local storage, it can pool it together, and it can create an object store on top of it. So that is sort of the relation. It is, local storage being local to a node is great if your application never moves or if your node never fails. But if
I was thinking more like distributed database, that kind of thing, where you need some IO performance. But yeah.
I think ceph being distributed can actually improve the performance of even slow disks if you have the right setup, and that can be true for object storage also.
I have more questions, but I'm going to hold on to them because you might answer them
okay.
in the presentation.
Sure. I'll continue on then. I think I got all the content here on the slide. I do want to talk a little bit about how Rook uses COSI currently. So there is what I have often kind of colloquially explained as a proof of concept predecessor to COSI, which exists, which is a lib bucket provisioner API, which Rook uses to provide object bucket claims. And this allows users to claim object storage, which is fulfilled automatically, which we implement in Rook, but this is not specific to Rook. These OBCs can be implemented by other operators as well. But this is a nice starting point. This is what, this was the kind of proof of concept for COSI, and it's something we see our users asking questions about it. I think that's a really good sign for COSI. And that's why we're engaged in the COSI community. And that's why we're starting some work to integrate with the alpha version of COSI and hopefully be one of the first people on this train. So just to finish up, I want to kind of thank some people who have helped me along my COSI journey, being Chris, John, Sid, Jiffin, and Jeff, who are both upstream and then also my coworkers here at Red Hat. And I think they deserve a shout out. I think we can open it up to the full Q&A.
All right, thanks, Blaine. So we talked about specifically with the container storage interface and that being focused on file level and block level storage. I think it might be helpful for the audience to take a step back and to understand the use cases and how these are actually being used by applications so that people understand the different types of storage, because you hear file, block, and you might not know the difference in when to use one or the other. Sometimes it is actually applicable to use both, in different ways. But maybe you want to talk about what, like coming from OpenStack specifically, we've used a lot of virtual machines kind of deployments, and then using block storage to clone images of virtual machines, to which then those would be the root file systems to those virtual machines. And then in theory, right, with it being distributed throughout Ceph, your virtual machine is fine. And in terms of like those clones, you're saving a lot of data. You're saving a lot from data in terms of having to not have to rewrite those images, but instead do writes on top of those images. So it provides, storage efficiency with that. However, maybe with object level storage, we could talk about, in terms of an application using Bodo or something like that, and how that all hooks into where the operators, I guess, actually, the operator deploying a pool, an object storage pool through Rook, and then how an application would actually utilize that.
Yeah, okay. I think there's a lot there to talk about. I guess first, yeah, talking about like block and file. I do also tend to think about block storage like virtual machines. That is kind of like, if you want a virtual machine, you have a block device that you install it on, just like any sort of raw hard drive that you install, Linux on in a server. I also have seen like a lot of like standard databases, like SQL databases, will just take a block device to get installed on. And that is another way that I've seen block storage used in a Kubernetes environment that is not just to provide VMs. For file storage, I think that comes up a lot with it's kind of more traditional, like enterprise. I want to share files between these different organizations, and is a pretty easy go-to. It's like, well, I just want to put some files in. I kind of like have them already arranged in structure. Things fit pretty well there. But there is, because of, I guess we're talking very technical, like all the like Linux inodes and things, there is system metadata that's required for file systems to locate things kind of in the directory tree. From OpenStack, I think if I remember correctly, the system that kind of hosts the like images that you would use to install a VM on a block device is generally object storage. It's like Manila in OpenStack.
Glance.
Yeah.
Glance. Sorry. Oh, I think Manila was file storage. That's right.
Yes.
It's been a while. But yeah, so OpenStack is a pretty good example of like where block, file, and object are all used, and then the glance storage is, I think, pretty similar to my example of kind of a package repository, since it's just sort of a repository. Like, here's this image you can use on your VM.
Since you brought up databases, I can actually give you a good example of a common practice from the database world, which is that for primary storage, for the actual, live data, databases will use block storage. If they're using, network storage, either local block storage or network block storage. But if it's available, we actually like to put backups in object storage, because we think of each backup as a single unit. We're looking for maximum availability for it, and object storage works much better for that.
Well, I really love this because I get to learn stuff too.
Yeah. Following up on actually Mike's question, I have a specific question about how this is going to work with how it's going to work with applications, right? Because right now, if I'm running a database and I'm sending my backups to object storage, and I'm doing it in Python, then I'd use Boto if I'm on AWS, and I'd use the Swift library if I'm an OpenStack, and presumably I would use something else for Google Cloud, but I don't actually know that much about Google Cloud storage. So is it the idea that we would eventually get specifically COSI libraries in the major programming languages, or are we aiming for compatibility with one of these specific object storage things, and we're just going to reuse those libraries?
I think the idea is reuse. I haven't used Boto, so I don't know exactly what it provides, but I can say that for AWS, it provides an S3 interface, and Rook also, well, Ceph really is the thing that provides an S3 compliant interface. So if you have an application that sends backup data to AWS, it's already using S3. And so you can just sort of point it to Ceph, and it should just operate the same way. There are sometimes features that Amazon implements a little bit before Ceph might get them, but largely like the base is still there. It is COSI just makes it easier to in a Kubernetes native way, just create a manifest that says, I want some object storage. I need like 30 gigabytes of it, or I need 3 terabytes of it, or maybe I need a petabyte of it if you have something really huge, and then that will go and it will look at the bucket class and see, okay, this ends up being provisioned by Rook, or this ends up being provisioned by Amazon, and then the operator for Rook or the operator for Amazon will go, it will create the storage. That operator will then figure out what the actual credential details are, and then populate a secret, and then the user can actually sort of look at the information from what they requested and see, okay, the status says that it's provisioned now, and it says that here's the access class that I can look at to get my access credentials, and then just mount those into a pod and go.
So it sounds like COSI will be Kubernetes agnostic as to whether it's Amazon's Kubernetes, OpenShift, or whatever Kubernetes version you're using to connect to the database, or in this case, the storage, I would say, versus database.
Yeah, I would say that's true. It's just a matter of whether or not there is an implementation for the storage that exists.
For what it's worth, object storage is the example of why the line between what is a file system and what is a database is not only extremely thin but non-existent at this point. It's really whether it's a file system or a database, it really depends on which project or vendor it came from.
Right. Yeah. Blaine, are there any more slides or anything else you're going to share? Because I was going to ask you to close your screen sharing. If not.
Oh, no, this is the last slide.
Okay,
cool.
I guess I could have ended with Q&A. But...
No, that's fine. We're all talking here. I just realized that the slides are still being shared.
Yep.
I wanted to add something on with what Blaine was mentioning, and specifically with Ceph supporting S3's API. So we have in GitHub, under the Ceph GitHub org, you could look for the S3 tests repository. And what's neat with that library is that is the whole test suite that we are using to ensure Ceph is actually compatible. We actually found that other libraries use it as well to make sure that they're compatible with S3. So there's been a lot of investment done by the Ceph community in terms of making sure that this works. And so what's great is that with the Rook development, as Blaine was mentioning, that, focused around with the S3 API. I mean, you can ensure that if Ceph works with it, then the S3 API is going to work with it too. So you can provision both in you could provision both in Amazon's EC2 if you wanted to do your own object inside of there and not use S3. But yeah.
Part of it, I think I'm still wondering about the whole, client-side language thing, because like I've worked with Boto extensively, and the problem is that Boto is designed to interface with AWS, so it handles all of the authorizations, for example, as part of the class. And obviously, we're actually, when it's accessing COSI, we're not going to want to have it do that. Or we're going to want to have it do, because presumably, so the authorization is actually being handled when you instantiate the COSI connection. Yes.
Yeah.
So
Wait, actually, can I speak on this one?
Yes, please.
I think there might be confusion. So with Boto, we're thinking like as the client, the user that is actually going to be reading and writing the data. What we're actually doing with COSI is this is more on the control plane side. So as the operator who's actually making that bucket, that object pool, and then buckets available to users that then would use it on Boto. So Boto then is connecting to actually as authorizing through Ceph itself through monitors at that point, not through monitors, but actually your key and secret, as I understand, your access key and secret. So, and then you, as the operator, you're able to give access to those buckets within that pool, to a set of users. And then from the Boto interface, you are, doing your puts and your gets to those buckets to interface with them from your application.
So you would send your authentication credentials through COSI, which would then translate it and send it to Boto?
No, COSI is not in the data path at all. So You have your application, and then you have Ceph over here. And Ceph, your application is talking directly to Ceph, reading and writing. COSI is not in the picture. As the operator, though, who has to make the servers do something and have the buckets available so that the application can actually read and write data to them. So the operator, then they're using something like kubectl, for example, to use Rook to deploy using the COSI interface so that those buckets actually exist in the Ceph data storage pool.
Okay. So COSI's role is effectively wholly administrative.
Yeah. That's what it sounds like.
So in some ways, making it analogous to CSI is a little bit deceptive, because CSI actually attaches, a block or a file system to the individual containers, which is not something we're going to be doing with COSI.
You know what? Oh, yeah, I'll let you speak on that.
I think that is kind of where the analogy breaks down. So CSI is also not in the data path, but it does also help to mount block or file storage automatically into containers, and that's not quite as possible with object storage, because it is, object storage applications have to say, here are my my authentication credentials with my username and my key, and I need to, authenticate to the S3 interface, whether that is backed by Amazon or whether that's backed by Ceph. That is just sort of kind of what the application knows. And I think a lot of times that is, to my understanding, mounted in different ways. It can be an environment variable that says, here are my credentials, or it can be like a file that the application reads also.
And there's also, so in CSI, we have, where we make volume claims, for example, but we still have sort of that concept, as I understand, with even the existing container storage interface that we're using today, of making certain claims. What exactly are those resources? I'm pulling up the source code now to remember, but you might know off the top of your head. Blaine?
The do you mean like the slide notes, the like persistent volume claims and such? Is that what you're asking about?
Yeah, so there's like the bucket claims that I'm seeing in here, for example. And on those, like when you're, as I understand, like those bucket claims, like that's to actually provision the bucket that the application would use. And you're able to set various additional configs in the YAML, such as like the maximum number of objects that you want to allow as a policy. You can also set the max size for that bucket as well. So in a way, it's like you provision volumes to containers and then they mount them, or they can use an HTTPS interface, for example, and write out to buckets instead. Either way, from the ceph standpoint, it all goes to the same storage cluster. It's just sliced out into different pools.
Okay. And I'm not going off into left field here. I'm really interested in that second path, because that's the new thing with this, right? Because like I'm used to, if I've got an application that's Python and AWS, then I run my thing. I have Boto. Boto creates a connection, an HTTPS connection to some Amazon S3 bucket, which is purely sort of a network service. Within Boto, it handles all of the authentication and authorization in order to gain access to that, and then I upload a copy of my backup to that, right? It sounds like that's going to be enabled, but it also sounds like there's kind of a second path around making a bucket claim that's different from that. That's not HTTPS. So what I want to know is how that second path works, because among other things, I've never found the authenticate and authorize for every single request ideal. So if there is a second path, I'd like to know about it.
Yeah, I guess like talking about the Amazon example, because we're talking about Boto. Like my understanding is that Boto also helps you sort of programmatically create object storage in Amazon and then get credentials about how to access that.
Mm-hmm. Well, not just create it, but also, because basically I'm trying to figure out what
your audio, I think.
Did we?
Nope.
Oh, I can hear you.
Okay.
Okay.
I'm trying to figure out what the role of the bucket claim is in here,
Mhm.
right? Because if you're just doing pure HTTPS authorization, etc., there's no real role for a claim, right? The volume exists, and if you have the correct credentials, then you can access it, or the bucket exists, and if you have the correct credentials, you can access it. So what role does the claim play?
The claim plays the role of so I guess if I step back a little bit and I assume that I'm a user of a Kubernetes cluster, there is a the COSI operator for Amazon is running. I can write a manifest that says, okay, I need object storage, and so I'm going to make an object bucket claim resource that says I want object storage, and then COSI will see that, and the Amazon operator will actually create that storage and provision it and make sure that a bucket exists and that a user exists for that bucket, and then so the details around actually creating an object storage bucket and a user to access that bucket are done at the Kubernetes level, so that you can write an application that says, okay, I'm connected to some object storage that uses S3, and so I'll use part of the Boto library maybe to read an environment variable that says here's my user, and another one that says here's my access token, and then I will just access whatever bucket. From there, I will upload my backups, or I will upload whatever files I have The one of the things that COSI also allows is applications that are ephemeral. So if an application wants object storage, but it doesn't need it for a long time, then COSI also handles the create this bucket and then also delete this bucket when the application is done running. And so it abstracts away the create this bucket and make a user for this bucket and then give me access details. Like that is all handled. And in that way, I think it should be possible to write the same application that uses either Rook and Ceph's S3 interface or Amazon's S3 interface in a way that the application actually doesn't need to know that there's a difference.
Okay. I mean, obviously that's a good thing because, for example, within the Python world, there's a lot of higher level applications that are written that embed Boto. And so having that still work is terrific. I do actually kind of wonder about sort of limiting ourselves to the S3 workflow, just because one of the characteristics of S3 is it's slow, right? I mean, deliberately so, right? It's designed to be slow, but highly available. But that's not a characteristic of object storage necessarily, right? That's a characteristic of S3, right? You can construct it. If I have a local Rook cluster on my local SSD storage across the nodes in my OpenShift cluster or whatever, that's actually fast. It's fast to access and it's fast to store things. And I'm wondering if by modeling this around the S3 interface, if we're disabling use cases that might benefit from having fast object storage.
I think that's a good question. COSI also is focused on being sort of vendor agnostic, and I would consider S3 kind of part of a vendor. Ceph provides an S3 interface, but you also could just talk to the Rados gateway directly. So there could be a sort of driver in place for that. In the COSI upstream meetings, we talk about all the big cloud providers. Azure has their own non-S3 interface. I think they call it blob storage, and they have their own access methods. And so just like there might be an Amazon and S3 driver of sorts with COSI, there also would be an Azure one or one for GCP. I think they might also use an S3 compatible interface, but I could be wrong about that.
I mean, all of this is also disappointing to me because, of course, the OpenStack folks built Swift to be an open standard, but everybody is focused on S3 compatible. It's just because I'm looking at this, and this is just like a really small example. So, pardon me for being very narrow here, but all of my personal hands-on experience with object storage is through my time as a database engineer, right? And so, like, to give you an example of sort of fast versus slow use cases, right, is in the Postgres world, people use object storage extensively for backups, right? Snapshots and backups, right? Because those benefit from high availability, high throughput, but can be slow to access. But like one thing that you don't do in the Postgres world, if you're just looking at S3, is unless your database has a very low quantity of changes, you wouldn't put your replication logs into S3 because it's too slow. Because like on a database that's really busy, you might be producing, 16 replication logs a second. Which doesn't work with the sort of S3 workflow where it might take several seconds to upload an individual one. But if you actually had fast object storage available, then suddenly that becomes a viable option, and you could do something like, say, broadcast replication, where one database writer puts those replication logs into object storage, and then multiple readers are able to pick up individual copies of those as objects. So I'm just wondering, we look at maybe in the medium term, looking at, is there a way that we can sort of make it possible to do fast object storage through COSI, or is that already possible?
I think it should be already possible. I guess I have a bit of a follow-up question, which is, when you say S3 is slow, are you talking sort of specifically about Amazon's implementation of S3? Or is it the S3 like
So
API interface itself?
Yeah,
Yeah.
both.
Okay.
Both, right? Both. There's the whole network implementation that is optimized for high throughput, high availability, slow access, right? You got to make your cloud trade-offs. That's the set of trade-offs they decided to make, and it is super useful, right? For one set of use cases. But then the second thing is every request I make, every object I write, goes through the entire authentication and authorization path via the API. And that authentication and authorization takes a significant amount of time when you're comparing it to the amount of time that's required for a local file write.
Right.
It would be more ceph's problem, not COSI, because COSI is still on the control plane side.
Yeah.
Yeah.
Yeah. I think I can provide a little bit of an answer here. So let's let's say that ceph is able to provide the S3 interface faster than Amazon is able to provide it. You could, in the same sort of multi-cloud cluster, or even if a Kubernetes cluster were just running in Amazon, you could create a bucket class that is, standard S3, and you could create another bucket class that is, called like fast S3. And if I, as a user, am like, okay, I have a database, but it's very active and I want fast S3 backups, then I could create a bucket request for that fast S3 class, and then get that faster storage, versus if I'm like, well, this database just, takes in information occasionally. So it can be a slower process. So that is how, if you had both a fast and a slow S3, you could have both that exist. And you could even have the same application, just with different usage patterns. You would just say this specification for the application uses fast S3 and this one does not.
Is that an option on S3 to have faster storage performance with S3?
That would just
Or you just
wouldn't that just be a question? Wouldn't that just be a question of how you configure the physical storage and network?
Yeah.
Well, that's what I'm saying. Like that's a great thing. If you're deploying your own sort of object storage cluster, something like ceph, you can have the idea of where you have different pools dedicated to object storage. And those pools, you could have one that specifically that has, say, fast SSDs, if you have found that is more performant with a Rados gateway sort of setup. And you can have another pool that is just spinning disks. And then it then matters on where exactly you're deploying those buckets. So as the operator, I'm going to use kubectl to, change the state with CRDs, as I understand. So changing the state as, here's a bucket that I'm going to go ahead and provision by claiming, here's a set of attributes, here are the users that have access to it, here is the policies, the quotas that should be set on it, go ahead and provision it. And then the work operator is going to go ahead and kick things off with the orchestrator API, as I understand. And from that standpoint, on ceph, you have your physical, racks. One is fast with SSDs, one with spinning disks. And from the ceph standpoint, though, you set it up where they're each their own pools, and you provision those buckets on the solid state drives. And then from there, the access key and the secret that you give to the user, they then plug that into their application. However, they're interfacing with S3, since ceph is both Swift and S3 compatible. In theory, you don't have to even change anything in your applications so that it can begin doing read and writes. And from there, it authenticates with the access key and secret key. And as I mentioned, like COSI is not in the picture at all at this point. It's just between the application and ceph directly.
But it sounds like if I'm looking for faster object access than the S3 API provides for, then I do need to rewrite the application to use Libratos instead of using S3 libraries.
Why is your application accessing the control plane though? That's
No. It's not accessing, it's accessing the object storage. Like here's the core problem with the S3 API in terms of write speed, right? So I'm producing 16 objects a second. For each one of those objects, I need to authorize and authenticate before I can write it. In terms of the speed of writes, that's a lot of time.
okay. Well, I mean, I could speak on the Rados gateway standpoint though.
Yeah.
It's one authentication, and then from there you are a single object, because you know you're not going to upload an entire, like in one chunk, a gig. So it breaks it up into chunks, and it uses multi-part uploading, to which then the authentication is only done that one time, because at that point you have a token, and you're using that token for each chunk that you are uploading to the bucket. So from the Rados gateway standpoint, I mean, we use the S3 API just for compatibility. You know, I don't think that affects our performance, because it's just how you tell it what to do. Ceph is, you know, in itself different in terms of its implementation of whatever S3 is using underneath.
Okay, but so getting back to COSI, so if I've created this bucket and the bucket access class and authorization via COSI, I can access that with Rados also if that's something the client application speaks. Yes, no?
I think the answer is yes. The application would have to have a little bit of like leaky information in that case to know that the S3 access credentials it was provided will work with via Rados. Alternatively, there's definitely room for us to explore whether like providing a Rados like plugin to COSI is also something that makes sense. So even if it is ultimately backed by the same object store, being able to have two different interfaces to it is something I think that would be possible. We haven't really planned that far ahead. I think most people are really interested in S3, so that's been our focus. But it is, I don't know. This has been an interesting conversation for me, because I'm like, oh yeah, there are actually other avenues here.
Yeah. So that brings up a sort of a follow-up question, which is that if I want to get more involved in discussing the spec and use cases that go beyond S3, where do I show up?
COSI has several different repositories. I think there are some links that should be shared with you all. It has a controller and an API. I think there's another interface as well. Honestly, the best places to probably go are the Kubernetes Slack channel, and then look for the I think it's just called COSI, but to look for the like container object storage interface.
Are there
channel.
any meetings that someone could join?
Mm-hmm. Yeah, the Kubernetes community calendar also has on Mondays and Thursdays sometime around like 11 or noon Mountain Time. So there's actually a meeting going on right now for COSI while we're talking. But yeah, on the Kubernetes community calendar, there's the information. I think the meeting on Monday is a little strange. It will request a password, which is just like 77777 to get in. But the community is very, very welcoming, and there's always a lot of discussion about like, what do users need from this? What do we need for alpha? How do we envision this kind of sort of evolving in the future? So I would say the Slack channel and the upstream meetings, if you can make those, are really the best place. Or if you're interested in Rook, we also have the Slack channel, and we have a Rook community meeting that is every other week. I think that's linked from the github.com/rook/rook README that's displayed on GitHub.
Okay, we've had a lot of comments in the channel, but not
No question.
not anything
Yeah.
that amounts to a question.
Drop these links again for
Cool.
the repos.
Yeah.
Not as one line, preferably.
Blaine, was there anything you didn't cover yet, but you think is important to mention in our closing minutes?
Absolutely. Yeah.
1.6.
Yeah, I guess shameless plug for Rook. We are dropping the newest 1.6 release later today. Is
nice.
is the plan, unless something goes terribly wrong. But yeah, we have a pretty smooth process at this point. So yeah, that has some changes I made to be able to handle much larger Rook ceph clusters as far as like number of OSDs. To help upgrade them a little faster. We're also able to support multiple file systems, which has been a beta feature, but it's now a GA feature. And then we have some first-class NFS gateway support also. Yeah, those are my release notes for today.
Cool.
Wonderful.
Okay. Well, I mean, I think we're at time.
Yeah, I mean, we've got 7 minutes. If there's nothing else, I think we can wrap this up if you want.
That was awesome. I'm excited about it.
Yeah, I am too.
Yeah.
Right? Like, there's a lot of potential here,
And a lot of questions.
Yeah,
which we've asked,
is
and some
good.
of them are more like what we would use it for and how we would do it. And Josh brought up points about databases, so then I'm going more in database lines of questions, and it's like, no, that's not our discussion.
Yeah.
Yeah,
I think that was my fault. Sorry.
No, it's also my fault because that is, like I said, that is my entire experience with
yeah.
object storage, right? Is using it for database use cases, right?
Yeah.
I mean, I also used it for CDN use cases,
Mm-hmm.
but frankly, I feel like the CDN use case is a lot more cut and dried.
Yeah.
I mean, maybe I never actually was I was never in charge of a CDN. If I was actually running the CDN rather than just using it, I might have a different opinion. But it's hey, what applications are not currently making much use of object storage, particularly because our whole conception of object storage is S3 and that sort of workflow that is not inherent in object storage. It's just, that's one example of object storage, and it made certain specific trade-offs.
So back when I was working on, go ahead, Blaine.
Oh, I just wanted to say, for all of you here I'm chatting with, but anyone also watching, if you're like, wow, this like COSI sounds really exciting, I would like to be able to make use of this. Obviously, it's in alpha and things aren't GA yet, but if you're interested in it, I think it's also really helpful for the upstream community to understand what use cases people are excited to use it for. And that also helps us make a better design, because we can understand like really what are the things that people care about. So yeah, definitely check in the Slack channel, or like the stand-up meeting, or either one of the COSI meetings if you can make it. Just say, hi, my name is Blaine. I'm here because I'm interested in integrating COSI with Rook, and I want to make sure that we can get what we need out of this, and that it's going to meet what our users want. So that's sort of how I entered into it.
Awesome. Well,
cool.
Without
Thank
further ado, yeah, thank you so much for sharing all this with us. Like, my mind is now open a little bit more to what's going on. So thank you. Yeah.
Yeah, this was really great, Blaine.
Yeah,
exciting new developments, and now when I see what is it that COSI is going for beta on the Kubernetes PR stream, I'll know what it is that you're talking about.
Yeah, I'm really excited for that moment, particularly.
Yeah.
I think that will be when it's when we've seen the alpha stage and say, okay, take a few
I
more lessons learned and really make something great.
I honestly think you're going to see higher than usual levels of beta adoption because
Yeah.
I'll tell you, as somebody right now who writes a lot of glue code to enable all the buckets that I need on S3, et cetera, that's hackish as all get out. And so COSI doesn't need to be all that stable to be better.
Right.
Yeah, I think
It just
that's
has to
actually
be
really,
that much more.
yeah, that's what's really surprising to me. Actually, I'm surprised that between Google and Amazon and Microsoft with Azure, no one has been like, we can make this a little bit better and then get the leg up.
It's been weird. I mean, I mainly have experience with the Amazon flavor. And it's been weird to me how slow they have been to enable sort of storage things on their own distro of Kubernetes, because they have all of these storage options. And it's just been slow, which is good because now it means that we actually get a standard version rather than one that's particular to AKS.
Yeah, I'm pretty excited about it. I think it's going to be great.
Yeah, exciting stuff ahead for sure. So thank you very much for joining us. Thank you for watching today.
And our next, we're not going to have Cloud Tech Thursday on the next cycle, 2 weeks from now, because that will be Red Hat Summit,
which you can get into. We're giving away free passes, aka it is free.
Yeah. but if you're into watching this channel, OpenShift TV is going to be hosting a series of office hours the week of KubeCon Europe. Most of them after the end of the day for Europeans. And we'll touch on a lot of the same topics that you normally see on this channel. So do look at OpenShift TV for that schedule.
Yeah, and if you would be so kind as to subscribe to the calendar, I would really appreciate that. That way you know what's coming up next, and you can see if it aligns with your schedule. So awesome.
For
Thank
any
you.
OpenStack folks, PTG is next week, so join us. Registration is also free. And I'll pick up a URL to put in the channel as well.
Is that PTG for everybody, for all the SIGs?
Yes.
Or projects?
All the projects, and all the projects under the foundation itself. So Kata, Zool, Airship,
the whole lot.
Starling X, and of course, OpenStack.
Okay. So you're going to recruit some more speakers out of that?
I already got a CERN.
Yep.
All right. Wonderful. You say, okay. Thank you, Amy. All right, folks, we're going to sign off for the day. We appreciate you tuning in. Hope you learned a lot, and we will see you soon.
Take care, all.
Bye. Thanks.